Hi, in case you don't know me, my name is Michael Tyson. I made Loopy and Audio Bus and the Amazing Audio Engine, which is what I want to talk to you about. The Amazing Audio Engine is now well over 3 years old and it's getting a bit long in the tooth. The platform's moved on a lot and there are plenty of features that I now need which are getting a bit awkward to roll into the existing code base. So a couple of weeks ago I decided it was time to start with a clean slate and build something that was going to continue to work for many years into the future, be extensible and all of the good things that a library should be. And the Amazing Audio Engine 2 has come out of that. It's come out of discussions with Jonathan Liljedahl. Sorry, Jonathan, if I've just mangled your name. You might know him from AudioShare and AUM, his own projects. The idea that he had and the idea that the Amazing Audio Engine 2 is based around is that of a buffer stack. It basically works like a scratch pad that you can push buffers on and push and pop buffers off in order to produce and process audio. That sits in contrast to a graph kind of layout, which is how the Amazing Audio Engine 1 functions, which is where you have a graph of nodes. So you have an input that might go into a filter, that might go into an output. You can have groups of things. I've done away with all of that in favor of a much simpler approach based around this buffer stack idea. So the way it works is you have a renderer. That's your very top level audio processing block. It works by interacting with a bunch of modules, which in turn interact with the stack. And that's it. There's no groups, there's no filters, there's no connecting one thing to another. You're basically just invoking modules one after the other, however you choose. So what I want to do, and this is going to be a bit of an experiment, I want to go through the process of making a fairly simple sample app live with you now, just to give you an idea of how it works. I figured that would be the easiest approach right now because I'm not quite up for writing the full kind of developer programming guide just yet. So doing it this way lets me get the message out quickly and hopefully gives you a bit of an idea of how it works. So I'm just going to make a really basic application here. I'm going to do it in Swift. We'll call it TAAE demo. I'll put it there. I'm going to add it to the existing project workspaces to make that easier. So here we go. So I'm writing in Swift, but as always, all audio code has to be in C. Not Objective-C, not Swift, but C itself, because both Objective-C and Swift, they do various kind of memory management, lock holding kind of things, which are not safe for audio. So what I'm going to do is make a audio engine class. Again, it's in Objective-C. Select Coco class. I'm going to call it AE demo audio controller. So I'm going to let it create a bridging header so that I can then interact with the audio engine from Swift. So I'm going to import AE demo audio controller. All right, so the next thing to do is import the Amazing Audio Engine. Okay, now just make sure it builds. Good, we're set. So what I'm going to do is expose start and stop methods on our audio controller that we can then call from Swift. So let's do that here. And in the initializer, I'm going to create an instance of the output. Now, the way that the Amazing Audio Engine 2 works is unlike 1, where you've got the audio controller and all interactions go through that. The Amazing Audio Engine 2 is a lot more modular. So you have a output unit, which controls all of the input and output with the actual hardware. And then you give that a renderer and give the renderer your render loop code, which we'll do now. So in the render block, which is the top level of your audio processing, you're given a context every time it's called. And the context contains a number of pieces of information that you can use to do the rendering. It's got the buffer list that you have to render to in order to actually produce output, the number of frames, the corresponding audio timestamp, and the sampler rate. And most importantly, it gives you the stack, which is a class that is instantiated by the renderer itself. And that gives you a pool of buffer lists to play with in order to start producing audio. What you then do is pass that context into the various modules, which are actually the audio processors. So just to kind of have somewhere to begin, I'm going to use the oscillator module, which is a good kind of test case just to make sure the code works. So what you do is you create an instance of it outside of the block, and then you use it inside the block. And of course, because we're using blocks, it gets captured automatically. So memory management becomes a lot easier there. So I seem to be having problems with autocomplete right now, so I have to type this manually and keep looking things up. So now that we have the oscillator, we just invoke it within the block like this. Now we just need to hook up the start and stop so that we can get the audio engine running, and hopefully we'll hear it. I'm going to do this in the app delegate just to keep it simple. Okay, let's see how that goes. So I'm just going to run it on the iPad Air here. And we're not going to hear anything right now because I've just processed the module and I've not actually put the audio onto the output. So let's do that first. So now that we've processed a module here, this module is going to push a buffer onto our stack. Now the buffer is sitting there basically doing nothing at this point because we need to then take the buffer and put it onto the output. So there's a utility that lets us do that. It is mix to buffer list. So what we can do is run a buffer stack. So what that does is it takes the first item that's on the stack, it outputs it to channels 0 and up, which means that if you've got a multi-channel output device, you can specify any channel you like to begin copying buffers over. So you can put any channel onto channel 16, whatever you like. We want it to convert mono to stereo so that if we have headphones plugged in, it's not going to just come out the left channel. And we put it onto the output that's given to us by the renderer. Now that that's there, we should be able to run it and hear a tone. So that's a fairly boring example. Let's make it a bit more interesting. So instead of an oscillator, I'm going to use a audio file player, and we'll make it a loop. So we need a piece of audio to do that with. What I'm going to do is grab everyone's favorite, the almond break, which is, as it turns out, already bundled with the sample app that comes with the Amazing Audio Engine 2. There it is. So what I'm going to do is make sure it's building into the project, and I'm going to create a audio file player module. So I'll delete the oscillator. So I'm going to make it loop indefinitely. So we just go amen.loop equals yes. That should do it. So oh yeah, we need to start it playing first. Okay, so what I'm going to do is go and play at time. Play at time lets you synchronize the beginning of any track so that you can make them all come in at the same time. in sync with some other event. I'm just going to use 0 for now so it starts playing straight away. Okay. And you'll hear it loop. Right, so now we have an album. Probably could use some effects. What I'm going to do is I'm going to add a bandpass effect that we can control with the slider so that you can change the way that the sound works. So what we're going to do is create a bandpass. We need to get a reference to it so that we can obviously change its parameters later on. So a bandpass, what is it called? AE bandpass module. Now, in order to use the bandpass module, all we need to do is process it immediately after the content we want it to process. So in this case, we use another AE module process and pass it the bandpass. Now, the bandpass module and all other effects work on the current buffer. So if there's no buffer, they'll do nothing. If there's 5 buffers, they will operate just on the top 1. So in this case, it's going to operate on the only one that we have there. So if we now run it, hopefully we'll hear something. There you go. The next thing is to make that interactive. So I'm going to add a slider to the demo app here. So that'll do for now. Now we need to hook it in to the view controller. Thank you, that's very helpful. Right, that's not very helpful. I'm going to do this myself then. Right, so now we need to get access to the actual bandpass effect so we can change the parameters. So we'll just make a member here that is a audio controller type. And we need to link it in from the app delegate. And then we can make the bandpass module publicly available. So we'll make that a read write, and then read only here. And finally, we should be able to calculate and assign the bandpass value. Okay, so let's try that. I killed it. Oh, of course, it's not min, max. Let's try that. Cool, that works. All right, so we've got generation and filtering. Let's try for recording. There's also a recorder module which takes the top buffer and writes it out to a file. So let's work that into the chain here as well. So it's called the, I can't remember. Let's see. Modules, taps, AE file recorder. There we go. AE file recorder. So usually you don't want to record the entire time, you just want to record while you are actually recording. So I'm going to add a button that will toggle recording and then we'll hook it in. But what we can do is actually use a utility class that's included in TAE2 called managed value. What managed value does is it lets you provide access to objects on the audio thread that can change, and it does all the memory management and updating in a thread-safe way. So what we'll do is we add a managed value. Actually, I'm going to make it a property here. So its value starts out as nil. So what we're going to do is set it later on. But on the main thread, what we do is we get the value. So we're going to be using a AE file recorder module. It's going to be unsafe unretained because we can't do any strong variables on the render loop, because otherwise it will retain it, which is not what we want. So what we do is we use AE managed value get value, which will return the current value, and it will be valid for the rest of the time until you call it again. So we can rely on the fact that if recorder is set, it's going to be valid for the duration, and we can then check to see if it's nil or not. And if it's not, we can use it. So we'll go AE module process recorder. Okay, so that's not going to do anything right now. We need to create the recorder and start it. So we'll make a property here called recording. And we'll make a setter which will act on it. I'm also going to make a computed value which will tell us what the path is. So like the player, we tell it to begin recording now by setting it at 0, and we're going to then pass it over to the render thread by setting the managed value. So we go self.recorder value dot object value equals recorder. So by setting object value, the AE managed value instance is going to change the value, retain it, and then if it ever changes in the future, it will handle the release at a time when it's not going to crash the audio thread, hopefully. So that'll begin recording. Now we need to facilitate the stopping of recording. So we say self.recorder value.object value. So we fetch it again, and we tell it to stop, and it is a file recorder module. And then we can set it to nil. So we've started recording and we've stopped recording. Now we just need to hook it up to a button in the interface. Going to set the title to record, and when it is selected, we'll say stop. Now I'm not falling for this one again. I'm going to write the action myself. Right, so we hook it up, run it, and hope for the best. Okay, so in theory, there's now a recorded file sitting in the documents folder. So what I'm going to do is cheat here and actually look in the folder using iExplorer. And there it is. So if we now, can we play it from here? No. I'll just move it onto the desktop and open it from there. And there we go. Right, so we've got playing, filtering, and recording. Now I'll just briefly show you how to capture input from the microphone, and then we can have karaoke fun times. So what we do is there's another module which will generate audio that comes from the mic, and we get that from the output unit so that we're using the same audio unit. That is important on iOS because if you ever intend to make an inter-app audio filter, an interrupt audio filter takes input from the same unit as it presents the output on. So here's how we do that. So it's called an audio unit input module. Now you can create an instance of that on its own and use it, and that will create its own audio unit. But we don't want to do that because of the aforementioned interrupt audio pain. So instead what we do is we take it from the output. In order to do that, we actually need to get the output a bit sooner. So we're going to put that there. We're going to put that there and then grab it here. Okay, and that's all we need to do. Now we just need to process it. So what we're going to do is do it in a separate chain here. So we're going to run it here. Now at this point we have two separate streams of audio. There's the first buffer, which was pushed by the arm and brake player, and then there's the second one, which was pushed by the input module. The first one's been processed by the bandpass. The input, well, let's process it as well. Let's add a delay, because delays are fun. And just to keep it musical, I'm going to set the delay time to a fraction of the Armin loop length. Divide it by 16, see how that sounds. Now we have two separate streams. We need to mix them together so that we can both record them and send them to the output. Now you can send individual items to the output, so we can have this copied here, for instance, followed by a buffer stack pop. And that will put the arm and brake to the output, clear the stack and let us do other things. But what we want to do is record both of these mixed together to the recorded file. So we need to mix these buffers. So what we can do is use AE buffer stack mix stack. And we want to mix two buffers. So at that point we should have the arm and brake with the bandpass applied, the input with the delay applied, and they'll be mixed together, recorded, and then sent to the output. So let's see how that sounds. Probably quite feedbacky right now. I'm just going to turn the volume down because otherwise we will get nasty sounds. Okay, no sound because we haven't set the audio session category. We need to set the category so that the iOS audio system will allow us to actually receive audio. So we're going to go AV Foundation. Shared instance, there we go. Set audio session category. Set category. There we go. So we're going to use AV audio session category play and record. We're going to allow it to mix with others because it's usually a good idea in a multitasking context. And we're also going to tell it to default to the speaker. Session category option default to speaker, there we go. That means on the iPhone it's going to play out the speaker and not through the receiver. Right, let's see how that works. Okay, I don't know if you can hear it, but we'll record it and play it back. Okay, so I'm going to stop that and we'll just grab the audio file and play it back. So that works, and now given that this video is about as long as anything that has ever been made, it's probably about enough to be going on with. I've only really just scratched the surface of what is in the Amazing Audio Engine 2. If you take a look at the source code of the sample app that's included in the repository, there's a whole lot more stuff there, like using variable speed filters to change the playback rate, doing stereo panning, changing the signal path depending on whether the headphones are plugged in or not. That's particularly important for the mic example because you don't want feedback. There's a bunch of other things in there. Take a look. It's a bit of fun. It looks like this. So there's a couple of loops, you can turn them on and off. Some things that will play one-shots in time. There's the varispeed and our bandpass effect, as well as recording, playback, and sharing. So a few things in there to get acquainted with the Amazing Audio Engine 2. Anyway, that's it for me. I can barely use my voice anymore. I hope you like it. I'd love to hear your feedback, and I will see you around. Cheerio.